Thanks for watching my video today. Then let's discuss some limit or some limit, okay? Which is also a very nice limit. Here, limit n tends to infinity, n factorial over n to the n power n to the power 1 by n. When you see all of this to the power something, okay? Let p is equal to limit n tends to infinity, n factorial over n to the power 1 over n. Now I want to take out this 1 over n, the power 1 over n. So what we need to do is we need to take our logarithm. Log p is equal to limit n tends to infinity log of this one, which means 1 by n log of this. And n factorial is, we know that 1, 2, 3 and so on up to n. This is n factorial, and n to the n mean n to the n means what? N to the n means n times, okay? N times, okay? And so on up to n times. So here we use log of x to the y is y log x. That's it. So our log p is equal to limit n tends to infinity 1 over n and log of, let's write it down, this one, 1 by n. Let me divide this to this and 2 by n, 3 by n and so on up to n by n. Do not cancel these two, okay, because they are different. Now we need to apply this. Log of xy is what? Log x plus log y. So let's use this. So log p is equal to limit n tends to infinity 1 over n log of 1 by n plus log of 2 by n plus log of 3 by n plus and so on up to log of n by n. Now let's find out the summation in terms of n terms. This one I can write in as summation from r equal to 1 to n log of r by n. Okay, when you put r equal to 1 and you get, when r equal to 2, then you get this one summation. Okay, now in definite integral as limit of sum, and that we know that integral from a to b f of x dx is nothing but limit h tends to 0 h f of a plus f of a plus h plus and so on up to n times. So this I can rewrite in as limit h tends to 0 h sum from n equal to 0 to n minus 1 f of a plus rh, where nh is equal to b minus a. This one we know already. Now put a equal to 0 and b equal to 1. That means our h will be 1 over n. When h tends to 0, that means this one, when h tends to 0, that means n tends to infinity. Then you get here. So replace everything by this one, 0 to 1 f of x dx, which is now limit n tends to infinity 1 over n, sum from n equal to, no, r equal to, yeah, this r, okay, r equal to 0 to n minus 1, f of r by n. Because a is 0 already, so r h is nothing but 1 over n, so this one. So that means replace limit this n, this one, summation by integral from 0 to 1n, 1 over n by this 2 you replace by this, and 1 over n replaced by dx, and this is nothing but f of x. Now let's us apply here. Same thing. So all log p is equal to limit and this summation replaced by integral from 0 to 1, and log of r by n is replaced by x, and 1 over n is replaced by dx. So if you simplify, now if you integrate this using what, integration by part, log x into x integral from 0 to 1 minus integral from 0 to 1 over x into x dx. If you do this, log p is equal to, this will be cancel out 0, and this will be cancel out again, so minus integral from 0 to 1 dx is nothing but minus 1. So our log p is nothing but minus 1. That means, but we want to find out this limit, which is our original is p, okay? So I want to put p, so our p will be e to the negative 1, which is nothing but 1 over e. In other words, I can write that limit n tends to infinity n factorial over n power n to the power 1 over n is nothing but 1 over e.